Okay, so what I want to talk about today is something called the halting problem. And this was a famous problem that was proposed by Alan Turing, who was like a famous British computer scientist. And what he wanted to ask was, does there exist a program, call it H, that takes an argument of another program and its input and lets you know if this program halts or loops. So P of I halts. Right, so the question is, does there exist a program H that will tell you if P of I halts or P of I loops? So sort of like a meta program here. And the answer is no. And here's why. So we want to assume that this program, this meta program H exists. So you have H, P of I, and if P of I halts, it's gonna output halts. And if P of I loops, we're gonna output loops. Okay, now we're gonna construct a new program, K, which takes in some other program P. And now it's gonna call H, P of P. And we're gonna do the same thing. And we're allowed to have, because what this is saying is this is like doing like P of P. And we can have the program take itself as an input because we assume that it's just like a string argument. So this is fine. And if H, P of P halts, then it's going to output loops. Right, so here what K is doing is it's giving you the opposite answer of H, which is fine. But here's where the contradiction comes in. So now let's see what happens if K called itself. So if K called itself, look what happens. So here, this line is saying that, okay, our program H said that K of K halts, but really K of K is looping. So this is a contradiction. And then here, H predicts that K of K loops, but really, we say that K of K is halting, so here's another contradiction. And so we look back up, and this turns out to be a proof by contradiction, because our construction of K of P was valid, plugging in K was valid. So the only thing that could possibly be invalid is our assumption here, that this thing exists. So by contradiction, there does not exist a program H that can tell you whether any program halts or loops.